Hello, everyone. How's everyone doing? I'm happy to be the first one after the keynote. So today I'm here to make you dream of a world. Can you hear me? OK. And it's one world where you don't have to use passwords anymore. Now, you might think that someone who works, for example, in an identity and management access company would know a lot about passwords and how to get around with passwords and so on. But I want to tell you about one of the many stories I've had with passwords, and I'm pretty sure you have dealt with this as well. And it's one of those things when you wish you didn't have to rely on your memory to do something as simple as paying with your credit card. So a few months ago, I was in a furniture shop, and I went to the self-checkout cashier, and I wanted to pay with my credit card. So I'm using the contactless thingy, and usually it doesn't ask me for a PIN, but of course that time it asked me for my PIN, and I didn't remember my PIN. I just didn't. So I'm like, OK, let me go to the bank's application and check my PIN. I go to my phone, get to the app, and I normally sign in with my fingerprint, and this time I was required to use my password, which of course I didn't remember either. So here I am in this self-checkout cashier, and I'm starting to sweat because it's been around 10 minutes of me trying to figure out how to pay. And I eventually managed to pay, but not before getting a 6-digit code sent to my phone, so I can then unlock the app, so I can then use my PIN. And this isn't the first time that this happens to me. And yes, I do use a password manager to store my passwords, but I just didn't store that particular password. I forgot to do it. And the truth is, passwords suck. Does anyone agree with that? Yes, you're my people. They do suck. And one of the problems with them, is that they rely on your memory. We have to remember our passwords. We have to make up long passwords. And it's just, with everything that we have in our minds, with our day-to-day things, it's just easy to forget. Passwords can also be vulnerable, and so they could be stolen by and then used by unauthorized people. The ticky. OK. Is this muted now? Hi. Hello. Hi. OK. Let me switch hands. All right. Where was I? Oh, yeah. Passwords suck because they can also be reused by unauthorized people. This clicker is great. OK. Hello, everyone. I'm Carla, and I work as a senior developer advocate for Auth0 by Okta, which happens to be an identity and access management company. So you would think I would, get around with passwords very good, but I don't. I also been working as a software engineer for the past 10 years or so. Sometimes I make YouTube videos. And you can find me as CARLA URREA almost everywhere, because in some places it was taken, but Before we dive in, I have a few disclaimers to make. The first one is, I might simplify certain things to try to explain them in an easier way. And the second one is, whenever you see a QR code, feel free to scan it, because I brought a bunch of resources. I will also share these slides on my Twitter or somewhere. We'll get around that. So any resource that I share here is also available to you all. What we're going to be talking about today. So first things first, I'm going to share my dislike for passwords. Already started doing that. And then we have a bunch of to-dos. OK. There? OK. We have a bunch of to-dos. We are going to talk about alternatives, and I'm going to talk about these two things called WebAuthn and passkeys eventually. So If we don't use passwords, what is the alternative? I think the slide already gave you the spoiler, but it could be passwordless, which could be pretty self-explanatory. But if we get to a fancier definition of that, passwordless authentication is any form of authentication that doesn't require the user to provide a password at login. And now there are some different types of way you can implement passwordless authentication. Some of them are, for example, when you use a magic link to send to your email to log in, or when you get a code through an SMS to your phone. But there are many other ways to implement passwordless authentication. Where am I pointing? Okay. Now, I do think passwordless is better, and I have a few reasons to believe that. The first thing is it improves the user experience. So for your users, they only need to remember their email or their phone number if they want to log in, or maybe their username if we want to get creative. So there's no need to remember passwords. There's no need to remember anything else. That's on one side. I also believe that this clicker hates me. Okay, can I get to see my slides in the TV? Because I'm like, come on. You know what? Okay. So I also believe passwordless is more secure. And I will expand on that in a minute. But for now, I think we can all agree that passwords can be vulnerable. We reuse passwords. And we can also share them with other people. And if you use any streaming services, you know that's the truth. Over 90% of web application attacks are due to credential abuse, like stealing your passwords. Now, passwordless is more secure because you need to add a second factor to prove your identity. And I'll expand on that in a minute. Another reason why passwordless is better is because it reduces the cost of ownership, both in time and emotionally. Managing passwords is expensive, and we were having conversations about this yesterday with some folks. You have to handle password expiration, password reset policies. You have to hash them. You have to store them. Please don't store them in plain text, please. And yet, you can use a gem for that to help you out, but it's still annoying to deal with. But it can also be incredibly scary. How many of you have had to implement an authentication system for your application? Okay. And I don't know about you all, but every time I had to do that, I'm like, ooh, did I miss anything? Is this secure enough? Is this vulnerable? It's just stressful. It's stressful. And if you have felt the stress, you're probably wondering, okay, if passwordless is the alternative, how does it work? Before we get into how does that work, we need to talk about authentication factors. And there are mainly 3 authentication factors. And those are knowledge. That is, you need to prove you are who you say you are using something that you know, like the answer to a security question or a password. There's possession, and that is proving your identity with something that you own, like a device. And then there's inherence, and that is proving your identity with something that you are, something that is inherent to you, like any biometric, like your fingerprint or your face, if you use Face ID recognition. And now, because in passwordless we're getting rid of the password, we're getting rid of the knowledge factor. So we're only using a possession factor. We can authenticate with something that we own, or the inherence factor. We can authenticate just by existing and using your fingerprint. Okay, you can see this image correctly. And there are a few different ways you can implement these factors. And like I said, there are a few ways to implement passwordless. There's sending magic links. There is sending one-time codes and push notifications and using authenticator apps and whatnot. But you're already giving, like, I'm already giving you a little bit of a spoiler with this image. But the thing is that when you combine multiple factors, you are adding another layer of security to your system. But depending on the authenticator type and factor that you use, you can increase what is known as the level of assurance. And the level of assurance refers to how confident you are that this user is who they say they are and not an attacker or someone just messing up with your system. One of the ways to increase that level of assurance is by using public key cryptography. I'm not going to go in depth about this one, but chances are that if you've used Git or GitHub, you've used a form of public key cryptography, which with SSH keys, for example. And in a nutshell, in a public key cryptography, there is a public key, and that is public for anyone. Anyone can see that. And there is a private key that is only known to you, and you need to store that securely. And any information that you encrypt with your private key can only be decrypted with your public key, and vice versa. So we talked about having multiple authentication factors. We like that. And then we add public key cryptography to, just make things more secure. But we also want to make this phishing resistant. And for a system to be phishing resistant, every party involved in the authentication process needs to prove identity. But they also need to prove intent through deliberate action. And this sounds very fancy, but what it means is that you need to somehow assert or confirm that you want to authenticate or that you want to create a new credential. And this is where WebAuthn comes up. WebAuthn is actually short for Web Authentication API. And it is a browser-based API that allows servers to register and authenticate using public key cryptography instead of a password. This is a W3 recommendation that's been around for a few years already. And I might throw a bunch of questions to you, but I'm curious to know if you've heard or used WebAuthn as of today. Okay, I see a few hands. Are you guys from 1Password or something? Okay. Because they were like, yeah. So yeah, WebAuthn uses public key cryptography to register and authenticate credentials, and it also uses a hardware authenticator that could look like this. Another question to the audience, anyone owns one of these? Okay, now these are called security keys, and we have a few of them in this picture. We have Google's Titan, we have the YubiKey by Euruko, which is this one I have right here. But what this device does is, this is the one that is going to be in charge of creating that key pair of public and private keys and to store them securely so you can authenticate. These type of authenticators, like the YubiKey, are known as roaming authenticators. But you can also use an authenticator like your Mac, for example, with the what's the name? Touch ID. And this would be known as a platform authenticator. But I've been talking a lot about WebAuthn, but I want to show you how it looks like in action with a little demo. And finger crossed that this video works. So we're going to see. Hi. No, it's because I think I have my speaker notes here. But it should work in the... Hello? Okay. Believe it or not, there's a video in there. Oh yeah, there you can see it. Yeah. Okay, wait. I'm gonna show you the video like this. Where am I? Let's click play. But before I got distracted, what I'm trying to do is show you how WebAuthn works and how to create a new WebAuthn credential. So, Nope. It just doesn't want to. Go to the slideshow. Doesn't want to. Please play.
Yeah, let's.
I am connected to the Wi-Fi.
Yeah, let's reload it a little bit.
The Wi-Fi?
No, the slide.
Okay.
Yeah.
I need to drag it back. Where am I? Uh-huh.
Yeah.
Does that work? Don't you just love this to happen? This is the best. I love it. Okay, let's try to refresh. Am I still online? Okay. Let's see. La 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 la. And I love this. The weird thing is we actually tested this just this morning, and of course it worked. And it doesn't work here either. Okay. You know what? I have the videos downloaded, so I might just...
Do you have it saved on?
Yes, I do have this saved, because we don't trust the internet sometimes.
Yeah,
Da 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 da. One sec while I find this. Can you see what I'm doing? No.
Yeah, let's try it out again. So that's the slide.
Okay. No, let's go to... Let's see if we can play it there. You have to click on it.
Now I'm on a mobile. Yeah, okay. Let's do that. Check. Okay, so yeah, it happens from time to time with the internet. So we'll switch to another internet next time. But maybe at this stage you have any questions? We had one I've checked on the type form about any password managers, but I encourage you to use the QR code if the one that we had for the questions to Carla while we're fixing that. And yeah, and also for the forum about the unconference talks. So one thing, while I have a chance to hold the mic, is that we have expo stage, which is the second stage. And this expo stage is empty in the morning until the after lunchtime. So it's completely yours. So if you want to gather people to have a fishbowl talk, or if you want to have a panel discussion talk, just come to me or anybody from the organizing team and say like, hey, I need 1 hour for the expo stage in the morning. I want to do some raffle, or I want to do some coding exercise, or I want to do something that, for example, you know, I want to bring a problem and talk to the people. So don't miss this opportunity. So for tomorrow, even still today, the expo stage is empty, and you can use it for any purpose that you have. And let's see if we can do anything. Oh, you're switching to the offline version, right? Yeah. Okay. So good. We going to have a couple of interesting raffles with the very good things ready to hang out to the audience. So also,
Okay, let's give this a try. One more. Yeah? You have a question? Fingers crossed. Yeah, everyone please. This is why I didn't want to do a live demo, and as you see. Okay. Yeah, this is working. Yes. Okay. Good. We did it. But we gotta be quick. So, what I'm doing here, I'm gonna start the video again, and now this is where it's not gonna load again. No. Okay, so what I want to show you here is how to register a new WebAuthn credential. I'm going to use just the username, no password. And the browser is going to ask me if I want to create a new credential. So I'm going to click on Continue. Next, I need to use my fingerprint, touch my MacBook's Touch ID, and then I will be sign in. Later on, when you want to authenticate, the process is a little bit similar. But we go to sign in, and we're going to use the same username, Euruko 2023. But now the browser is not going to ask you to create anything new, just to use your fingerprint instead of the password. I mean, you can use the password, but who wants to do that? Let's face it. And now, this looks pretty simple from here, but let me show you how it looks like under the hood, like what is going on in that interaction. So, when you want to create a new WebAuthn credential, the first thing that needs to happen is that the user sends their username to the client, the browser. And so the browser then sends that information over to the server, which in the context of WebAuthn, we're going to call the relying party. The relying party then sends a cryptographically random challenge to the client. So the client can send it to the authenticator. That could be a YubiKey like that or your Mac. Now, before the authenticator actually does anything with this information, if you remember, I talked about intent through deliberate action, and you need to assert that you want to do this. So there has to be some sort of user interaction. I need to touch my YubiKey, or I need to put my fingerprint on my MacBook Touch ID to assert, to confirm that I want this credential to be created. After that, the authenticator then generates the key pair that it's going to use, and then sends that information back to the browser. And it also signs that challenge with those key pairs that were created. So we're going to send back the signed challenge, the public key, and a private key ID. Note that the private key is never leaving the authenticator. We're only saying an identification so we can use it later on. The client then sends that back to the relying party or your server, and then you can store that information, like the public key and the private key ID. Later, when you want to authenticate or log in, the user once again sends their username to the browser or the client, and the client sends that information to the relying party. And the relying party recognizes that there has been already a user registered with these credentials, so it sends back a new challenge to be signed and the private key ID, because we need to make sure that the challenge is signed with the same key pair that it was used when created. We send that back to the authenticator, and then again, there has to be a form of user interaction. So you tap your YubiKey or you touch your MacBook's Touch ID, sign the challenge, and send that information back to the browser. We send the signed challenge along with the private key, with the public key, and that to the relying party. So then the relying party can again verify, okay, this public key is actually the one that was used to sign the initial challenge that was used when creating the credential. So this is more or less what is happening under the hood. And this happens in the following way. So the communication between the client and the authenticator happens through an application protocol called the Client to Authenticator Protocol, or CTAP2. And the communication between the client and the relying party happens through the WebAuthn standard. Now, these two standards, the CTAP2 and WebAuthn, comprise what is known as FIDO2. And FIDO2 was created by the FIDO Alliance, and unfortunately, I can't see my notes anymore, so that's karma. But FIDO and I have a similar goal, which is getting rid completely of passwords. So as for now, if you want to learn more, you can scan the QR code, learn more about that. But as for now, I'm happy if you just remember that there is something called FIDO2, because we're going to get into that in a second. OK, so I show you how WebAuthn looks like. I showed you what's going on under the hood. But I said it was an API. So how does the API actually look like? It has a few methods, but the main ones are navigator.credentials.create and navigator.credentials.get. Now, the create method works to create those public key credentials, and the get method is used later on for authentication. I did mention that this was a browser-based API. That means that it's exposed through JavaScript. I'm sorry. Don't despair, though, because there is a gem. Of course, there is a gem. And this gem makes your Ruby or your Rails application or your web server become a WebAuthn relying party. So if you remember from that little diagram I showed you, the relying party was the one on the right. So this is the role that your Ruby app would have. I brought some code that I want to show you. And actually, the demo that didn't want to play in the beginning was actually built with the demo code used from this app. I'll just tweak it a little bit to, I made it purple. So feel free to check that out. But if we want to look at some code, if you happen to want to make your Ruby application a relying party, it would look more or less like this. So let's say you have a registrations controller and you have a create action. So you're going to create a new user, get in the username from the parameters, and then what you're going to do is you're going to use a relying party that you can define in your application controller. And with the gem, what you need to do is to specify who is this relying party. So we're going to say that the origin, in my case, was going to be localhost, and the name is WebAuthn demo because I am not that creative. So next up, we are going to use the options for registration method. And what we're doing there is we're kind of like setting up the payload that we're going to send over to the WebAuthn API. And we're sending here a few things. First thing is the user. So we're going to send the name, and we're going to use the username from parameters. The next thing is an ID. And you can use the WebAuthn gem to generate this ID. Because the important thing about this ID is that it's something that it could be completely random, but the important thing is that it doesn't contain any type of sensitive data. It doesn't have any way to identify your user from an external point of view. Another thing we are going to specify is the authenticator selection, and you see we're sending user verification required. So with the WebAuthn API, you can specify which type of authenticator you want to use. So if I say that the user verification is required, I couldn't use, for example, something like a YubiKey, because user verification doesn't necessarily mean user interaction. With the verification, I probably need to use something like my MacBook's Touch ID because it actually asserts that I am who I am. So that's on your server side. And like I said, it's JavaScript. So somehow in your front end, don't ask me how, because I don't know JavaScript, but somehow you are going to need to call the WebAuthn API. If you use React, there's a bunch of libraries there. I'm sure there's a bunch of libraries for all the other frameworks. But this is more or less how it looks like. And you can see the mapping is very similar. So we're calling navigator.credentials.create, and we're wrapping that into a public key object. So we're passing over the challenge. I actually missed that from the server side. You need to get the challenge before you send that to the browser. And here's where you use it. So we send the challenge, and as I said, this is a random value. We send information about the relying party with the name and the ID. Like I said, I was using localhost. Information about the user, and again, the authenticator selection. There is a bunch of other objects and parameters that you can configure here, and you can check that out in a bit. And once this happens, this is where that whole browser interaction starts to happen, when you have to use your fingerprint and so on. And so you get back a response with the public data that we talked about, the public key and the private key ID. So you can store that in your database and not be concerned that anyone will get that, because there's nothing to get, basically. Now, when you want to authenticate with a WebAuthn credential, let's say that you have a sessions controller and you have a create action. So you're going to fetch your user from your database, and once again, we're going to initialize the call for the get method with the options for authentication method here. And what we're saying is we're going to allow this user, the user with the WebAuthn credential, and this method is just making a reference to the WebAuthn.generate user ID we used in the registration process. We're also saying that we want to use the user verification again, and we're going to get that challenge. So we pass that along to our view, and once again, somehow front end needs to do this at some point. And you see that the code is very similar. Once again, you can add a bunch of other stuff. One different thing here is the transport, and that's, again, you can specify which type of authenticator you want to use. You can use it through USB, Bluetooth, or NFC. Okay, so I do think WebAuthn is actually better than passwords. And first of all, it uses private public key based authentication. And we know that the private key remains in the authenticator, so that's good. And we also know that you make it phishing resistant, because there has to be that user interaction in the middle. Everyone in the authentication process has to do something. Then you only store public data in your database, and it overall offers a better user experience. But most importantly, no more passwords. Yes. Now, if we go back to my agenda, as you can see, I have shared my dislike for passwords. We talk about alternatives with passwordless, magic links, one-time password codes, and WebAuthn. And so far, we got rid of the password, right? But I can't avoid to wonder if we can take things even further. So I no longer have to remember my password. But what if I didn't even have to remember if I have created an account for a website or not? And let me tell you, there is a way to do this, and that is using passkeys. Passkeys, this is Euruko, meet passkeys. Have anyone heard about passkeys before? Good. Do you use passkeys nowadays? Less hands, but some hands, so that's great. Now, passkeys are a replacement for passwords. And it's funny because, you know, we're replacing the word with keys. So it's just making it a lot better, in my opinion. Now, passkeys are intuitive because there's nothing else to remember. You can just assert that you want to use them and just use them. They're also automatically unique per server. You cannot reuse your passkeys at all. They are breach resistant because you are only going to be storing public data, so there's really nothing to breach. And it is also phishing resistant because it also uses public and private key cryptography and many other things. But if we get very technical, passkeys are FIDO2 discoverable credentials. And if you remember from that diagram I showed you earlier, where I mentioned, please remember the word FIDO2, FIDO2 uses CTAP2 to communicate between the authenticator and the client, and WebAuthn to communicate between the client and the relying party. And so that means that passkeys are using WebAuthn under the hood. But the thing is, a WebAuthn credential is not considered a passkey unless it's discoverable. And being discoverable means it's the ability that the relying party or the server has to already know or to discover the username automatically. Now you're probably wondering, okay, so we have now discoverable credentials. Why should I even consider to not work with discoverable credentials? And the quick answer for that is just backwards compatibility. Passkeys are very, very new. So if they've been around, I think that the name got popular probably in June last year. So they're still being adopted, and they're still very new. So there are some authenticators out there that do not support discoverable credentials. In fact, in February this year, the concept of passkeys changed. So maybe you'll see this talk 6 months from now, and there will be a new definition. This is how new we're talking about, and this is why this makes me so excited to talk about it. Now, there are two types of passkeys. We have sync passkeys and device-bound passkeys. Sync passkeys are those passkeys that you can use from the cloud, using, for example, a cloud keychain-based system, like, for example, Apple's iCloud. And device-bound passkeys are those that are bound to a device, like a YubiKey, for example. The cool thing about the sync passkeys, though, is that they will automatically sync across all your devices. So if you create a passkey using, for example, your Mac, and I'm using the example of Apple because I use Mac, but Google also has a version of this. But if you sync your passkey to your iCloud, then you can use it through all your devices. Let me show you how that looks. And I'll be honest with you, with this video, which I hope works this time, I use a little bit of my employee powers, and I'm using the Auth0 by Okta passkeys implementation, which is in early access. So what I'm going to do is I'm going to press play. I think I did it. And we're going to click on login. I apologize if it's too small, but here we have a login form. And this is a system that used to use password in the past. So what we're going to do here is that at some point in the video, I put my email, but it takes time because I thought I was going to take more time. Cool. CARLA@okta.com. It asks me for a password, and then it prompts me with this informational stuff about passkeys. Yeah, there's no need to remember a password, all the things that we talked about. So we're going to click on Create Passkey. Eventually. Yeah? No? There we go. Okay, Create Passkey. And once again, we're going to use our fingerprint to the Mac Touch ID to log in, and just like that, I'm logged in. So as you see, the process is very, very similar to WebAuthn. And like I said, it's because it's using WebAuthn under the hood. Now, later on, when you want to log in, we're going to click on login. And this is a cool thing. I'm already prompted my account name, like my email, without doing anything. So I don't have to remember absolutely anything. And then I'm going to use that. I'm going to click on that and just use my fingerprint, not my password, please, no. But as you notice, I actually used a password to log in into the system. And the cool thing about passkeys and passwords is that they can coexist together. Because let's be honest, migrating from password to passkeys can be challenging in the sense that we are used to passwords. So we need to now get used to passkeys. But yeah, you can use them together and they will work together. And then eventually you can migrate completely to passkeys. One last thing is the multi-device feature that I mentioned about syncing my passkey to the cloud. And that is, let's say I have my phone, and from my phone, I want to log in. Once again, if I go to continue with the passkey, because I'm using iCloud in this case, that passkey is already there, and I'm using my face to unlock it, to unlock the secret manager, and then log in. Just like that. Now, you might notice that I've been using my fingerprint for the whole time, and now I'm using my Face ID. And the cool thing about passkeys is that it doesn't really matter which type of authenticator you use, because what you're doing is just unlocking the secret manager. So, back to my agenda. I did share my dislike for password many times. We talked about alternatives. We talked about WebAuthn, and finally, we talked about passkeys. But moving forward, what else can you do with this information? Where can you use passkeys as of today? Well, you could get early access from Auth0 and use it in any system that uses Auth0. Google already supports passkeys, so does Apple, and so does GitHub. In fact, I actually created my new passkey last week for GitHub because I was being very paranoid about stuff. And I'm sure there will be many, many others, but you know, the big ones are already there. So I think this is going to be huge, so I recommend that you get on it. Another thing you can check is this website. It's called WebAuthn.me, and it shows you more or less the same flow I showed you here, but very interactively. It also has a debugger, so you can play around with the parameters you send to the WebAuthn API. You can register, you continue with the passkey, use your fingerprint, and then in the end you get a response and you can see what's going on. This website, this is completely educational, by the way. Like, this is all fake data and this is all pretending, but it works and it helps you understand that. And then about passkeys, you can go to passkeys.dev, and I like to think of this website as like one of the source of truth regarding passkeys, because it is actually hosted by the FIDO Alliance, and those are the folks who created all this stuff. You can also, I think that link is for you to try our implementation at Auth0, so you can do that as well. And boy, it's been a ride. It's been a ride with the videos not loading. It's been a ride with technical issues, but we made it. But most importantly, we managed to do all of this without using passwords at all. So, thank you very much, and enjoy the rest of the conference.